simple frame using flexibility method. We will only try to cover this problem today, and in the next class we will try to, or we will on Friday, that is tomorrow, we will start a new lesson. Okay, that is the stiffness matrix method. Okay, so here we were finding out the displacements d1l, d2l, and I asked you to tell me the values for this one, but somehow whatever values you have conveyed, it is wrong. Okay, so I am editing this part. I hope all of you, those who are writing, they can also they should also do that. Okay, so this I will remove. Okay, so this value, this d1l value, it is 26.67 divided by ei, and this value this value is different again. So Govardhan Reddy told me the answers. Govardhan, you please be careful with your integration in calculator. That is horrible. Okay, so so 3402.22 by EI. Okay, this is the answer. And next, this one D12, it is, the D12 value is 347.3 by EI. So you can hear from my voice that I am having some congestion, and I am having some cough and cold. Yesterday I was having some cold, so now it is fine, but still I am under medication now. Okay, so now we have found out the displacement matrix, that is, we have found out the d1l, this dl we have found out. Okay, so next is the flexibility method. So now this F11, what is this F11? So F11 is the horizontal displacement at D due to the unit load Q1. Okay, so this we can calculate as integration m1 square dx by ei. Okay, so if that is the case, so all of you please go back to your table and write that one, because I am writing it here directly. So it is integration 0 to 4 x square dx by ei plus integration 0 to 16 by 3 ei into dx plus integration 0 to 4 again 16 into dx divided by, this is 3 ei, I guess, yes, 3 ei, then plus integration 0 to 6 4 minus x whole square dx by 2ei. Okay, so this becomes equal to 86.67 by ei. This is what I got. You please check your answer. Okay, so this is F11. So we have determined the F11. Okay, so similarly we will determine F12, F13, F21, F22, F23, F31, F32, F33. Here, remember that these values f21 and sorry f12 and f21 will be same. Okay, next this f13 f31 will be same. Next f32 and sorry yes f32 and f23, these values will be same. Okay, so you have to, so only, so whatever, what will be different, the different values will be f11, f22 and f33. Okay, so these values will be unique, and for these two you have to compute only once, this only you have to compute once, again this one also you have to only compute once. Okay, so please work in a smart manner. Okay, so I'm adding one more page. Okay, so this is f2 f11, so f22 or f1, sorry f12 will be f12 equals to, so what will be f12, so f12 will be vertical displacement at d due to unit load q2. Okay, sorry. So it is integration m1 m2 dx divided by ei. Okay, so if you put all the values, so I am writing that one. Okay, this
It's M1 M2, sir.
in
Sir, it's sigma M1 M2, sir.
yes, so summation m1 m2.
Yes, sir.
Okay, this is summation, everything is summation only. Okay, so it is 4x 4x into dx by 3ei. This is 0 to 6, then plus, all of you please check whether I am writing it correct or not. 4x dx divided by 3ei, then plus integration 0 to 6 4 minus x into minus 10 into dx divided by 2ei. So if you integrate this one, you will get the value as 336.67 divided by ei. Okay, so similarly, I'm going to the next page. So f13 equals to, so what will be f13? So now f13 will be rotation. Okay, why rotation? Because q3 is a moment. Okay, rotation at d due to q1. Okay, so first see what we did. This f11 is the horizontal displacement due to q1, then f12 is the vertical displacement at d due to, sorry, this is q1 only. Okay, then the third one is again, so f13 is the rotation at d due to q1. Okay, so this will be summation m1 m3 into dx divided by ei. So that is equal to, so it is integration 0 to 4 x into dx divided by ei plus integration 0 to 6 4 by 3 dx by ei, then plus integration 0 to 4 by 3 ei into dx plus integration 0 to 6 4 minus x dx divided by 2ei. Okay, so this, if you calculate, it will be 24.33 by ei. Okay, so this is F13. So we have determined the values F11, F12, F13. So it means this one F11 is equal to F21. Okay, so this we have already determined. F13 equals to F31. So we have already determined. So now let us determine F22. Okay, so or let me write it so that others can understand. So I was writing in blank. So F21 equals to horizontal displacement at D due to load Q2. Okay, so this is again integration summation M2 into M1 into dx by ei. So this, if you put, so it is integration 0 to 6 4x dx divided by 3ei plus integration 0 to 4x dx divided by 3ei plus integration 0 to 6 4 minus x into minus 10 into dx divided by 2ei. So this becomes 36.67 divided by ei. So let me go to the next page. So F22 equals to, so what is F22? It is vertical displacement at D due to load Q2. So this is integration summation M2 square dx by ei. So this is integration 0 to 6 x square dx divided by 3ei plus integration 0 to 6 plus x whole square divided by 3ei plus integration 0 to 6. This is 0 to 4 actually. 100 into dx divided by 2ei. So if you integrate this one, you will get 411.11 by ei. Okay, so we have done calculated F22. Now we will calculate F23. Okay, so F23 equals to, so what is F23? It is rotation at D due to unit load Q2. Okay, so it is in summation integration M2 M3 divided by ei into dx. Okay, so that becomes integration 0 to 6 x into dx divided by 3ei plus integration 0 to 4 minus 6 plus x into dx divided by 2ei, then plus integration 0 to 6 minus 10 into dx divided by 2ei. So this becomes equals to minus 40 by ei. Okay, so now we have determined f11, f12, f13, f21, f22, f23, f31, f we have already determined, f32 also we have determined from here. Now we will determine f33. Okay, but still for others, let me write f31 equals to horizontal displacement at D due to load Q3. Okay, so that is integration m1, integration summation m1, m3 m1 into dx divided by ei. So it is, so that I am directly writing 24.33 by ei. So similarly, F32 equals to vertical displacement at D due to load Q3. So that will be summation integration F m3 m2 into dx divided by ei. So that becomes equal to minus 40 by ei. Okay, so similarly f33 equals to rotation at D due to unit load Q3. So equals to summation integration m3 square dx divided by ei. So that becomes integration 0 to 6 1 dx divided by 3 ei plus integration 0 to 4 1 into dx divided by 3 ei, then plus integration 0 to 6 1 dx divided by 2 ei. Okay, so if you calculate this value, it is coming as 6.33 by ei. Okay, so now if we put all the values, okay, so write down that one. So therefore putting all the values in the equation d minus dl equals to f into p, we have, so this d we already know what is. Okay, what is the value of d? The value of d is
0.
0. Okay, because there is no settlement, anything is of that sort is given. Okay, so the equation reduces to minus dl equals to f into p. Okay, So this implies, so if, so I'm directly writing the value 1 by EI into minus 26.67 minus 26.673402.22, and this is 347.3. This equals to 1 by EI into, this is 86.67, this is 36.67, this is 24.43, this is 36.67, this one is 411.11, this is minus 40, this is 24.33, this is minus 40 again, this is 6.33. Okay, and what about this one? So that is, this is HD, because we are taking the first one is horizontal, so HD, this is VD, and one, the third one is MD, that is, so this is the horizontal one, this is the vertical one, vertical reaction, and this is the moment. Okay, so please find the value of HD now, HDVD. So this implies, make the inverse and find the value of HD, VD, and MD. Please find the values.
Sir, what is the value of EI, sir?
EI do you need here? EI will be cancelled, no?
Yeah, okay, sir.
Sir, DL3, I think it's negative.
Huh? Yes, I have taken the minus sign here, no? DL3. Wait. Yes. Yes. Please tell me the values, calculate the values and tell me. What is the value? Find out. Govardhan,
Sir,
what is the value of HD, VD and MD?
they're finding, sir. Still finding. Not getting it's coming error, sir.
Hmm?
The dimension error it is coming, sir.
Dimension error. Why
Yes, sir.
dimension error is coming?
I think I do mistake in doing the matrix calculation, sir. I'm
Okay.
trying.
What about Sony? Sony, what is the value? Hmm? Harshvardhan,
Sir,
what is the value you got?
still I'm working, sir.
Okay. What about others? See, guys, one more thing. All of you attend the classes sincerely. Okay, Lakshmi Bhavani, what is the answer? Next, the question is for Padmavati. What is the answer? Hmm? Who will tell? What is the answer? How much?
Sir, it is not, sir.
It is not coming. Why
Sir,
it is not coming?
I'm trying, sir, but it is not coming, sir.
Now whose mobile is vibrating? This one? Hmm?
Sir, HD equal to 0.6, sir.
HD equals to 0.6.
Yes, sir.
Sure, huh?
I calculated this.
0.6. Yes, it is correct. 0.6017. This is so these are the values: 0.6017, 6.9003, and minus 13.5839. This is ton. This is ton. This is ton meter. Okay. So I calculated it using MATLAB. It is easy for me. Okay. So HD is 0.6017. It is then its VD is 6.9003. Then its MD is minus 13.5839. Okay, so this is the value. Okay, so now this is, so what is the unit of this one? What is the unit of this one? It is, what is the unit of this one? Govardhan.
Tons, sir. Tons.
Tons, it is also tons, it is in tons meter. Okay, so this is all about the problem. So we'll stop it here today and we'll start the next chapter, that is the stiffness method, in the next class, that is tomorrow. Okay.